When we store object data in HyperStore, we do so using either erasure coding, replication, or replicated erasure coding. Metadata, however, is only stored using replication, and we must have a means to determine how many replicas of the metadata there should be. Historically, Cloudian professional services have always deployed systems using 2m+1 as best practice for metadata replicas. However, this was applied at a global level and did not take into account any changes that customers may want on a specific storage policy. For instance, 2m-1 is preferred for distributed erasure coding policies. Functionality has now been introduced into the CMC to select the preferred number of metadata replicas for each storage policy. In the graphic shown, we can see the lower part of the storage policy creation window. As we can see, the system shows an option for metadata replicas. In this case, the policy is for erasure coding of 3+2 in a single data center. Selectable options available for metadata replicas are 3 or 5, with 3 being the default for this specific policy. Understanding consistency requirements is crucial for both storage policy creation and troubleshooting. As consistency affects replication and erasure coding in different ways, we need to consider the effect of combining both in a policy. Let's take, for example, an EC policy of 3+2 with a consistency level of quorum or eventual consistency. We need success for k+1 data fragments for writes and k data fragments for successful reads. For the replicated metadata, quorum means majority, and the majority of 3 is 2. To successfully write, we must achieve k+1 or 4 fragments. This equates to the number of fragments required to rebuild the single replica we're storing, and at least one additional parity fragment, giving us protection. In this case, we will assume we managed all k+m fragments. We must also achieve quorum of the metadata replicas. In this policy, the default of 3 replicas was selected and must be achieved eventually. Assume we then have a simultaneous loss of 2 nodes, and both nodes have metadata stored on them for this object. This leaves us with 3 fragments of the object data, as we've lost 2 fragments comprising of either parity or data, and we have 1 remaining replica of the metadata. For a read to be successful, we require k fragments of the object data, which we can achieve. We also need a quorum of metadata, which in this case would be 2, so is a failure. In this scenario, this object cannot be read. If you have already completed Cloudian certified training, then hopefully this short video is just a refresher for consistency policy and effect on both object data and metadata.